Okay guys, Mr. Palmer back with another momentum and impulse review. We're going to look at number 7, which is an elastic collision problem. So let's set that up. We know we're doing conservation of momentum, the momentum of one object, m1v1, plus the momentum of a second object, m2v2, is going to be equal to their total momentum after, so m1v1 plus m2v2. And going back into the problem, what's really important is keeping straight which is which. So we have a student, let's call that number 1, who's traveling 5 meters per second to the right. 5 meters per second to the right would be here. Right is positive. Attempts to ram Mr. Spencer's car, who's initially traveling 8 meters per second to the left. 8 meters per second to the left is going to be -8. That's his velocity. So this is number 1, the student. This is number 2, Mr. Spencer. It says after the collision, Mr. Spencer is traveling 1 meter per second to the left. So Spencer is 2, and left is negative, so he's going -1. And now it goes and tells us their combined masses. The student is 235, and Spencer is 270. Well, 235 kilograms for the student. 270 for Spencer, right? They're going to keep the same masses after the collision. Mr. Spencer's still going to be 270, right? He's going -1, that's 1 to the left. And we want to know the student's velocity afterwards. Well, the student's mass isn't changed. It's still 235, right? Times some new velocity. Now, if you look at this calculation, this is going to give us right here on the right-hand side, right? Mr. Spencer is going to have a negative velocity. He had a negative velocity before, and this student had a positive velocity. So we're adding a positive and a negative together on the left. We have a negative on the right, which we're going to add to the other side, right? Because it's negative on this side. You're going to wind up adding positive 270 to the right. And we're going to solve for this velocity by dividing by the 235. And if you do that, that's going to come out to be -3.04 meters per second. And the negative means that this is going to be to the left. And that should make sense. If we're looking at the total here, we have a much larger mass and velocity. We have a small velocity here, so that we're going to have a slightly negative velocity for the student. Okay, and I'll be back with number 8, one more elastic problem.